Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at your mathematics part of paper 2. Obviously you are well aware that we are still on trigonometry. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, Kuli, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So I suppose all of you guys are able to see that diagram over there. So what I'm going to quickly do is just to read through the given statement. And then from there, I'm going to take you through the questions and also the process that you should go about in answering the questions. Are you guys able to see the question paper clearly over there? Is it not blurry? Can you guys see clearly there?
Yes, sir.
Last one to confirm. Guys, can someone confirm if they are able to see over there?
Yes, sir.
Okay, so what I'm going to do quickly is to read through the given statement. Question 3.1, it says, in the diagram below, triangle QPR is a right-angled triangle with angle P in triangle QPR being equals to 90 degrees. So there's nothing surprising on that statement. There's nothing tricky about that statement. So this is a diagram which is a triangle having three corners being Q, P, and R. And most importantly, this triangle is a right-angled triangle with angle P being 90 degrees. Okay, is there someone who wants to tell what do you guys know or what do you guys have to say regarding a triangle which is a right-angled triangle? Anyone, what can you say about that?
So if it's a right angle triangle, it means it has a 90-degree three sides, and that you can use the three trig ratios and the theorem of Pythagoras as well.
Did you guys get that? I'm just not sure. It seems like the message is taking forever. You got it, Shreyas. Guys, Are you doing good that side?
Yes, sir.
Okay, so now here comes a question, being question 3.1.1. Remember, guys, very, very much important that you follow the numbering system used in the question paper. Make sure that if you are answering this question, you firstly write 3.1.1, and then from there you can continue in answering the question. So now determine the ratio of tan 90 degrees minus R. I'm not sure, guys, if there's any of you who'd like to give it a try. But most importantly, guys, check what is the cream of the question. Remember, the cream of the question is that word or those words when removed from the question or statement. The whole of it makes no sense. So can you see here it says determine the ratio. Obviously, you know very well that the ratio is actually something over something, which means your final answer should be in that form of something over something. Remember, this question is allocated 1 mark. So I'm not sure if there's someone who'd like to give it a try. Here's an opportunity for you to give it a try. Anyone to give it a try, guys? Remember, guys, in case if you've got no idea, please do mention to say no idea in this case, so that I'm well aware that you did get the message, but you don't know where to start. Then we'll try in different ways to see if we can get it correct.
No idea, sir.
No idea. So,
No idea. Okay. I see this one. I think we can say it's a bit tricky, but let's try it this way. Maybe let's try to reduce this. Can you see? You have 90 minus that. In which quadrant does 90 minus angle fall?
in the first quadrant.
So in the first quadrant, is tan positive or negative?
Is positive.
Positive.
Tan in the first quadrant is positive. So now, because of its 90, this ratio, does it not change? Just like if it was sine, we know it changes to cos. If it's tan, does it not change? Is there someone who knows if it changes or not?
So I don't think tan can change.
I'm not able to hear the honorable member speaking. Can you come again? I think you sound too low.
So it doesn't change.
She says it doesn't change. Because I know if it was cos, it would change to sine. Let's try to make a guess. Let's say if it's tan, it changes to cot. I just want to test something. If it changes to cot, then it means it is going to be positive cot of a angle R. So what is cot? Cot is 1 over tan of angle R. Let's maybe try to check if this assumption is correct. How do you check it, Kolahan? You can just assume that angle to be whatever number that you can think of. Remember, I like using 30, 45, 60. Can we try to use any of those angles to check if when we substitute there, we get the same value as when we substitute as 1 over tan that? Let me also try on my side. So that's if you are not sure of something and you want to try and check or prove if whatever that you're thinking is correct. Let's say tan of a 90, I'm going to use 30 minus 30. I'm getting the root of 3. What about 1 of tan 30? I'm getting the root of 3 as well. Can someone try with 45? Another one try with 60. It seems like it's giving the same thing. Let me check something. Can someone try to substitute using a different answer, guys? I just want to check something in the meantime. Mm-hmm.
1090 minus 60.
What are you
So I
getting?
can't see the screen now. I don't know what's going on.
You can't see the screen. Let me try something. Can you guys see the screen? The other guys?
Yes, sir.
Yes.
Kuli, try to quickly leave and then come back. It seems like the screen it's still okay. Someone was saying something. What were you guys saying?
So if I substitute 1090 minus 60, I get root 3 over 3.
Oh, so it's back.
Wait. Someone was saying something, guys. I want to write it down. Who was speaking?
It's 2 meters, sir.
It's Dumelo. Okay, Dumelo, what did you get? When you substituted there, what did you get?
So root 60, I got root 3 over 3.
Root 3 over 3. Mm-hmm. And then when you substituted there, what about when you substituted here? So remember, guys, what we're actually doing, Kolahani, we want to test if when you have tan into 90 degrees minus whatever angle, we just want to check if trig ratio of tan changes to cot. So we try to prove that by substituting any angle there, either 30, 45, or 60. When you substitute it there, and also when you substitute it here, of which the simplified thing there is actually 1 over tan. When you substitute it here, the same angle, it has to give you the same answer. So Tumza has substituted there, and this is what she's getting. So if we are correct, when she substitute there, she must also get square root of 3 over 3. If she doesn't, then it means when you have tan, it cannot change to cot. Tumza, are you getting the same thing or are you getting something different?
So when I substitute from 1 over 10 I get root 3. only.
Wait, when you substitute, what did you say? Okay, which angle are you using? I'll substitute. Which angle are you using?
I'm using 60, sir.
So that means you must say a tan of 90 minus 60 it's equals to that. Okay, so now over 1 at the bottom it has to be tan of 60. I'm getting the same thing, Tumsa. That means you substituted incorrectly. Remember, it's 1 over tan of 60. Nay. Can you quickly try to correct it and confirm if you made a mistake? Guys, are we together on this question?
Say in root 3, not
Hmm?
root 3 over 3. It gives me root 3 only. Then I say 1 over time.
Is your
90 minus
calculator
6.
on degree mode?
Yes. Yes,
Okay.
sir.
Start with one. No, a division sign. Start with a division sign, then punch 1 at the bottom, punch tan 60. Because you see you're using angle 60, isn't it? The other guys, can you please perform the same calculation, guys, so that we see if we're getting the same answer or not? Because if you're quiet, I'm no longer sure if I'm the one who's making a mistake or if Doomsa there is making a mistake.
Oh, yes, sir. It's root 3 over 3.
Yeah. So can you see, Doomsa? That
So,
means if you are given a tan and then the angle there is 90 minus or 90 plus. Even if it was 270 minus or plus, you know, when it's a angle along this line, your trig ratio has to change. But if it's a 360 and 180, it doesn't change. So now, in answering the question, let's try to reduce that. So we know very well that this falls in the first quadrant, and in the first quadrant, tan is positive. But because there it's 90 minus, then it means it has to change that trig ratio. So it changes to chord of angle R. So can you now see that we are actually now on that angle R over there? So what is the trig ratio for chord? Chord obviously is 1 over a, what is it? A tan R. What is the ratio for tan? Isn't tan opposite over adjacent? I hope you guys, you do know very well that tan is opposite over adjacent. So now let's see. That means we've got 1 over. What is opposite there? And what is adjacent there?
say opposite is Q. It's QP.
She's saying opposite is QP. What is adjacent?
It's
PR.
Someone is saying adjacent is PR. Let's therefore try to simplify this. Remember, it's the same as 1 divided by QP over PR. Remember, you always want to have a multiplication there. So it's multiplied by, you write that at the top, then it becomes PR over, you write that at the bottom, being a QP. So it's more like 1 times the whole of that. It ends up being PR over a QP. I'm not sure if I lost you guys on this question. Are we together there, or is there someone who's got a question, guys?
Yes, I understand.
Someone says they understand. Another one to confirm. Remember, guys, in case if you've got a question, you are welcome to ask a question based on that.
I understand, sir.
Okay, 100%. So, remember, guys, it's all about you understanding the given information that you can actually reduce that angle. After reducing it, try to then write everything in the form of a ratio. So, also, since this is capital letter P, that means this is small letter p. That is Q. This will be Q. This is R. Then this will be small letter r. So that means the capital R, it represents that angle. Capital letter P, that angle. Capital letter Q, that angle. So even if you write your final answer as what is PR? PR is small letter Q over what is a QP? QP is small letter R. You will still get a mark in writing your final answer in that format. So now, quickly, let's have a look at the next question. So you need to be very careful regarding what the question wants you to provide as an answer. Let's see. Question 3.1.2 says, write down the trigonometric ratio that is equals to QR over QP. What an interesting question. So they want you to write down the trigonometric ratio. Can you see the cream of the question? Trig ratio, which means your final answer, it must be something over something. Or otherwise, if it's not in that ratio, then you can just write it as it could be sine, it could be cos, it could be tan, sec, cosec, cot. So it all depends on what your final answer will be. But the question says, write down the trigonometric ratio that is equivalent to QR over QP. I'm not sure if there's someone who wants to give it a try, guys. Remember, in case if you don't have an idea, let me know so that I can straight away show you how to respond to this question.
Say,
Mm-hmm.
since actually, I'm not sure, but ever since like you have introduced those letter P, Q, and R, then I think you wanna say for QR, ane? For
Mm-hmm.
QR is P, then over for QP is P over R. That's the trick.
So is P over R. Why go kwela fase mara today? Ke tsore go kwela fase today Tumsa. O ka re o ka re phone ya go kitchen wena o go dining room. The Tumza. Okay. Let me write it down. So you say it's Q over R. Did you say it's Q over R?
No, say P over R.
P over R.
Yeah, yes, sir, that's the ratio for QR and QP.
Oh, no. Let's see. How do I respond to you in this case? Tumza. Of course, this is a ratio, but this is not different from a P R over a Q, what is it, QP. So it's more like in this case, of course, it is a ratio, but you still gave the question in your case as a form of an answer. So it's more like they say, how are you? Being a question, and you respond to me, you also say, how are you? I'm not sure of how to explain that one, Matumza. So can you see there? Write down the trigonometric ratio that is equals to QR over QP. So can you see? You just wrote the same thing, but with the sides in small letters. So let me give you a hint on that one, Dumza. I'll help you to get it right. So what they are basically saying is that give us a sine, cos, tan, sec, cosec, or cot as your answer. So it's more like it's given to you as a ratio, but they want you to give it as a trigonometric ratio. I think I'm noticing something, Tumza. So guys, I just noticed something. If the question says ratio, it means they want it in this format as something over something. But if they say trigonometric ratio, then they want you to say it's either sine, cos, tan, sec, cosec, or cot. Tumza, did you get that?
Yes, I'm getting it.
Tumza, thanks very much for that attempt. Can you see, it made me to realize something very much important. So in exam, that means you'll be aware that if the question says determine the ratio, then they want it in a form of something over something. But if they say trigonometric ratio, they want you to give it in that format. So now, Tumza, this is how you approach this question. Let's see. On that triangle, what is P? P is this one. P is hypotenuse. Do you agree, Tumza?
Yes, sir.
What about R? What is R in that case? Isn't
It's
R?
opposite, sir.
What is R?
It's opposite.
Oh, okay. So that means R is opposite to that angle there. Then let's try, Tumza. Which trig ratio has a hypotenuse and opposite? Which trigonometric ratio from that list has opposite and hypotenuse?
It's sine, sir.
Ke sine, ne?
Yes.
But we know that sine is equals to opposite over a, what is it? Hypotenuse. So what is the reciprocal of sine?
It's cosec.
She's saying is cosec. Is cosec. Obviously angle R, isn't it? Because you're saying we're using our reference angle as that R. So cosec, in terms of those letters, what is it? What is it? Obviously, we know that is hypotenuse over opposite. But in terms of the letters, what is hypotenuse and what is opposite? In terms of letters,
It's P over R.
is P over R. But let's forget about this one's dooms. So this one's I was just showing you from the first question to say, even if you assume this side to be small letter P, is still fine, it will be acceptable. If that as small letter R, it's fine. If that as that, it's fine. But let's use either QR, RP, or PQ. Let's use those instead of small letter R, small letter P, small letter Q. What is cosec R?
It's QR over QP.
QR over QP. Let's see. QR. There. QR being hypotenuse over QP being that one. So can you see? I think we are closer to getting the answer. Remember, the answer said write down the trigonometric ratio equivalent to QR over QP. I'm not sure. Is there someone who already noticed what the answer is for that question? Tumza,
Yes, I have no idea.
you have no idea, ne? Okay. You got the answer, Tumza. You got the answer already. I'm going to redo it again. But remember, you need to choose from sine, cos, tan, sec, cosec, or cot. Which trig ratio is equals to a QR over QP? It's cosec, Tumza. Cosec is equals to QR over QP. So that means when you answer this question, you just say cosec angle R. That's it. Let me try to explain it again. Let me try to explain it again. Just make sure that this time around you understand. Okay, so the question says, write a, what is it? Trig a ratio that is equals to QR over QP. Here comes the question. What is a trig ratio? Trig ratio could be cos, could be sine, could be tan, could be sec, could be cosec, could be cot. That's what they want, trigonometric ratio. So they want to know which trigonometric ratio is equals to this. Before I even answer that question, let me make it easy and ask you a question so that you will then understand this question. It's more like they are saying, which trigonometric ratio is equals to PR over QR? That's my question, guys. We are no longer answering the question in the question paper, but now answer my question. Write down the trigonometric ratio which is equals to PR over QR. What is that trigonometric ratio, guys?
So I think it's cos.
Yes, it's cos, because a PR is adjacent and QR, being that one, is hypotenuse. So when we say write the trigonometric ratio, you just need to choose from that and ask yourself, which trig ratio is actually adjacent over hypotenuse? Is it not cos, guys? It's cos. Can you see? So, Tumza, in this case, the examiner says write trigonometric ratio that is equals to QR over QP. So what you need to ask yourself is that in that right angle triangle, what is QR? There is QR. QR is hypotenuse. Over. What is QP? Where's QP? There's QP. QP is adjacent, guys. So you now ask yourself this question. Which trig ratios have hypotenuse and adjacent? You just ask yourself to say which trig ratios has a hypotenuse and adjacent. Which one is it?
It's cos.
Is cos, yes. So let's try to write it. Cos is the same as adjacent over hypotenuse. This is the trig ratio for cos. But can you see, in the question there, the arrangement is such that hypotenuse is at the top and adjacent is at the bottom, which means it's actually the reciprocal of hey, am I on the right track there? I think I made a mistake. Yes, I think I made a mistake. But with you, whoever said cos, you are correct in saying that, which means you are on the same page with us. Someone also noticed that I made a mistake. Let's correct it, Honorable. I noticed Tumza says I made a mistake. I agree with you there, Tumza. Let's correct that mistake. What mistake did I do, Tumza?
So it's not adjacent.
Adjacent. Yes, 100%. So can you guys see? It's easy to fall in the trap of making a mistake. So that's what examiner is trying to test, if you fully understand what the question says, and again, if you won't make a similar mistake. So that means you need to be very careful in this case. QR there is hypotenuse, and then QP there is opposite. So there you write opposite. So Lisa, now tell me, which trig ratio has hypotenuse and opposite? Not sure.
I think it's guess.
Yes, sir.
I couldn't hear Lisa, but I just heard Shreya saying yes. Shreya, which question are you answering there, honorable member?
3.1.2.
Which trig ratio has hypotenuse and opposite?
9.
Yes, it's sine. So let's see, sine we know is equals to opposite over a hypotenuse. Can you see? But now the trig ratio that we need to provide is such that hypotenuse is at the top and then opposite is at the bottom, which means it is the reciprocal of sine. What is the reciprocal of sine?
Cosec.
It's cosec. Cosec angle R. So that means this is the trig ratio that examiner wants you to provide as your answer. Cosec, most importantly, of angle R. You must write to say cosec of angle R. So all that I did here was just try and show you how you get to the correct answer. But you only get 1 mark for just saying a cosec of angle R. You can also try to answer this question differently by referring to angle Q. So if you make use of angle Q and not use angle R, you can still give the correct answer. You just ask yourself this question: which one is which and which one is which with reference to that angle over there? And then from there, you just answer accordingly in relation to Q. I'm not sure if you guys can be able to answer that question in terms of Q, or would you like for me to quickly do it? Someone can tell what should I do in that case? Do you think you can be able to do it? Dumza, do you think you can be able to do it?
So are we using that ratio, that QR and QP?
Yeah, so remember,
That
the question, it doesn't change. So the question still says, write down the trigonometric ratio that is equals to a QR over QP. So I'm just trying to say, an answer to this question is not only that one of cosec angle R. You can also make use of that angle and answer the question differently. But what matters the most is that in this case, your reference angle is that Q. Do you get it now, honorable member?
yes, I get it.
So do you think you can be able to answer that one in terms of Q? Maybe let me do it. Let's quickly do it. Okay, so this is how you do it. QR with reference to that angle, what will QR be? There is Q, there is R. It is still hypotenuse. And then QP. Where is QP? There is Q, there is P. So what is QP? Is there someone who knows what is QP? Is it hypotenuse? Is it opposite? Is it adjacent?
It's
Adjacent.
Yes, it's adjacent. So now, which trig ratio has adjacent and a hypotenuse? Which trig ratio do you know has
Cos.
that? Yes, is cos. So what is the ratio for cos? Cos is cos of angle Q being equals to adjacent over hypotenuse. So what is this ratio? This ratio, QR, you guys said QR. QR is hypotenuse, isn't it? Over. What is QP? QP is adjacent. So is cos an answer for that question?
No, sir.
No. So
No.
What is the trig ratio? No, the reciprocal of cos. What is it?
Sec.
It's sec. So that means this is sec angle. So what I was saying there, honorable members, is that even if you say sec but of angle Q, you are still going to get a mark, because sec of angle Q, it is the same ratio as that. Does it make sense now?
Yes, sir.
So, Tabiso, just make sure, sometimes, guys, with some of these questions, it might not be something that you could easily learn in class, but with attending my lessons, that's when you'll notice how to answer some of the other questions. So just make sure, guys, that you don't miss any of my lessons, because one thing for sure, some of you might not be understanding that. And the reason to that is because you missed my old lessons where I was teaching the basics of trigonometric ratios, the ratios, and also special angles, whatever. So for you to fully understand today's lesson, that's if you attended those lessons. But if you didn't, that's where you might be a bit lost there and there. So just in case if you missed those lessons, you can let me know. Then I will refer you to a link where you can watch the old lessons. Can you guys see this question? Let's see. I think it's not blurry. I hope you guys can be able to see. Let me just put it over there. Okay, so it says S, having the coordinates of -3 and -4, it's a point on a Cartesian plane such that OS makes an angle of theta with the positive x axis. I think almost everything is represented on that diagram. So I can just remove all of that. So remember, this question paper is posted in the group. So let's see. We have a Cartesian plane having the x and the y axis. The x and the y axis, and that point there is the origin. And we have got a positive angle. A positive angle is an angle that starts from there, or that starts from that line, and then it goes in an anti-clockwise direction. That's what it means by making a positive angle, which means if it was from there in that direction, is a negative angle. But in most cases, they give for a positive angle. You just need to be careful of which angle you're dealing with. So now, let's try to have a look at the questions. I'm not sure. Do you guys understand that information there? We've got a Cartesian plane, and we've got this in quadrant number 3, where point S has got these coordinates. Does it make sense to everyone there?
Yes, sir.
Okay, 100%. So now let's quickly try to see if we can answer this question. So the first question says, calculate the following. Hey, without using a calculator. So ladies and gentlemen, put away your calculators. We might need to use our head in this case. Let's see. 3.2.1 says calculate the length of OS. The length of OS. Is there someone who would like to give it a try in terms of how can we calculate the length of OS? So remember, guys, the reason why I'm saying anyone to give it a try is because I know I've taken you through this lesson before. We've been doing this question. So I'm just giving you guys an opportunity to also give it a try. Anyone who want to give it a try? Tumza the Tumza. Go for it, honorable member. Mara tumelo ku utlwella fatshe wa itse. I'm not really sure. Is it my thing? Let me try to do this. Tumza, can you try to say something?
Say?
Are you in the kitchen?
No, sir, I'm not.
But your phone is in the kitchen, ne?
No, sir.
Hey, ku utlwella fatshe Tumza, but it's fine. Let's give it a try. Just get closer to your mic, ne?
Oh, okay, sir.
Go for it.
So on the Cartesian plane, we have given
Mm-hmm.
a S. So that point S has the coordinates of x and y. So therefore, for the x value it's -3, then for the y value it's -4.
Mm-hmm.
So we are looking for OS, and OS is a
Hey.
Hyportunuse. Hyportunuse.
Yes, thank you. It's
Mm-hmm.
hypotenuse.
Mm-hmm.
So we're going to look for the hypotenuse, which is R. So we're gonna use Pythagoras theorem.
Yes. Yes. Okay. So that says r squared equals to x squared plus y squared. What is x? Remember, guys, make sure to substitute in brackets. So it is -3 squared plus -4 squared. This is equals to what? It's equals to r squared. What is this? This is 9. What is this? Is it 16? I think so. Let's see. What is this plus this? If you add 10 there, it's 10 is 25. It's equals to r squared. Then what is the root of 25? Is it not plus or minus 5?
5.
Yes, but remember, r is always positive, which means r is equals to positive 5. So we can just somewhere write it there as 5. Did that make sense to everyone? Are you all happy there?
Yes, sir.
Okay, 100%. So let me just remove all of that. That's how you score yourself 2 marks. So now let's move on to the next question. Can you see what the next question says? They want you to calculate the value of sec theta plus sine squared theta. Let's see. Sec theta plus a sine squared theta. Yo. And this question is allocated 3 marks. Is there anyone who wants to give it a try?
I have no idea, sir.
Lisa have got no idea. Anyone who wants to give it a try, guys?
So can I?
Yes, go for it, Dimsa. Go for it.
So, okay, sec, it's, so can you hear me?
Oh, yes. Continue.
So sec is cos, so it's going to be 1 over cos theta
Sec is 1 over cos of theta.
plus sine theta squared, close bracket squared.
Sine squared theta.
So then we wanna, since we have all the values, then we wanna say 1 over negative 3 over 5
Negative 3 over 5.
plus open brackets.
Maybe Tumza, because we still have grade 10 learners, can we maybe start it in terms of x, y, and r over there?
Oh, so it's gonna be x over r.
Oh, so the trig ratio for cos is x over r, okay?
Then should I? Okay. Then open brackets. Then it's gonna be y over r. Close brackets.
Yes, very, very much important, ladies and gentlemen. Remember to square that, because if you don't and you continue, okay, the Tumza, let's substitute. So here you said it's negative 4 over 5. Is this what you said, Tumza?
No, I said negative 3 over 5.
Hey, why negative 3?
So the x value to negative 3.
Ladies and gentlemen, be very, very careful. So when you substitute, make sure that x is x being x from the coordinates, plus obviously y is that value being there over what is it?
5.
What is, oh yes, 5. And then remember to square. Very, very much important, ladies and gentlemen, over there. So Tumza, maybe continue.
So when I continue, I think I'm gonna say 1 divided by negative 3. Plus, should I just say
Yeah. What are you doing? Uyenzani? Hey, machans, lamona ro utra shaya. Ikole tlhaga or ikule ke nna ke lete, Lungster. Okay, Tumza, go for it.
say you're gonna multiply 2 times negative 4. It's negative 8. Open brackets.
Hey. Okay.
Over. Over
10. Do you agree with that, guys? Do you agree with everything that she has done up to that point? Guys?
Yes.
Okay. Let me remind you of something, guys. If we have, let's say, b over y to the exponent x, Tumza, this is the same as it multiplies the power and not the base. So this is the same as b to the exponent x over y to the exponent x, which means that one is negative 4 squared over 5 squared, which means you have 16 over 25. Does it make sense there?
Yes, sir.
Yes. So just be careful of that, the dooms. So with you doing that, it means from this step going downwards, everything is wrong. Okay, so let's see. You have 16 divided by 25. Let's see. Continue.
So from that, I'm gonna say 1 times
Mm-hmm.
5 over negative 3
Mm-hmm.
plus 16 over 25 plus 16 over 25.
Mm-hmm.
Then say, oh, when a punch into calculate. 1 into 5 is 5, then 1 into negative 3 is negative 3
Mm-hmm.
plus 16 over 5, 25.
Mm-hmm.
We find the use of calculator. So from there, I think we're gonna say negative 3 plus 25. Yeah, and 25 times 5,
Mm-hmm.
then negative 3 times 16.
Wait. What do we do first, Tumza?
LCD, so.
Mm-hmm.
Yes, so we're gonna find LCD.
Okay. Maybe let me do this. Then what am I writing?
Yeah, wait, sir.
Kunzima, ne?
Yes. I forgot
Eh,
this one.
okay. Let me check. Is there someone who also wants to give it a try from this stage? Tumza, do you not remember me saying this thing? Hmm?
Yes, I remember now. Just the text of Orica plus Orica multiply. So now I know. Let's go, sir.
Okay.
I'm gonna say 25 times negative 3.
So if just like you were saying, Tumza, you are not sure, put it inside the brackets. When you put it inside the brackets, you therefore forget about that. So it's more like you're going to say negative 3 times 25. Can you see? Does it
Yes,
not make it easy?
it does.
And then from there, what do we do?
Then we're gonna say 25 times 5
5 times 25. Mm-hmm.
plus
Mm-hmm.
negative 3 times 16.
16 times negative 3. So can you see, Tumza, I firstly start with the numbers at the top. This one's at the bottom, they are visitors, so you write it second so that you write the sign of whatever that is there, the sign that was there, and also the number that was there. Anything else is just there as second. So now let's see, what is this times that? I think, is it 125. I think it's 125. Can someone confirm there? What is
Yes,
this times negative that? I think is 1548. Is it not 48?
it is.
Okay. So what is this times that? Is 50, 75, negative 75. Is it not negative 75?
It is.
Okay. What is this minus that? Hey, you got it on triple.
77.
Okay. 77. 77 over negative 75. Can this thing be further simplified? I don't think so. This thing cannot be further. By that, I mean, do you have a number that goes into 75 and also goes into 77?
No,
No,
sir.
no, no, no. So it
It's
just
zero.
ends as negative 77 over 75. So, Tumza, what I like about this type of questions is that you can easily prove it. How do you prove it? Even though they said don't use a calculator, but for the sake of proving or to check if this final answer is correct, can you guys punch that on your calculator and check if it gives you negative 77 over 75? Can someone punch it and tell me if it gives you that?
It does, sir.
Molefe, ngo ntumedishe mo, sa lo ntumedisha gale.
Hi, sir.
Kunjani lapho?
It's
Faith,
good.
Faithy, Neo, Neo, Neo. Amogelang Faith. Hey, these guys are watching the Queen there. Okay. The second one to confirm if this thing gives negative 75. Then we move to the next question.
Yes, sir. It does, sir.
So can you guys see that you can easily be able to prove if your answer is wrong or correct? But did you guys understand all of that? Are we on the same page on that one?
Yes, sir.
Yes.
Okay, so now let's move to 3.3. Sure, I so wish you guys can be able to get 4 marks on this one. Let's see. Determine the value of the following without using a calculator. Hey, I'll just write it down. Let's see. Remember, we are now on a new question. Let's see. So this is 3.3. Sure. What's happening there? It seems okay. 3.3. Let's see. 3.3 says cosec of 45 degrees over sine of 90 degrees multiplied by tan of 60 degrees. Is there someone who can tell us or guide us in terms of how can we approach this type of a question? Amogelang le Neo, Le right ka mo. Okay, it's fine. I'll explain to you guys this one. So remember, guys, always when you're given a something similar to this, where the angles are actual numbers, try to check if those angles are the special angles. You need to remember that we have the special angle for 45. I know it's 1, 1, and then is the root of 2 there. And then we have another one for 60. I think for 60 is 1, the root of 3, and then 2. And then we also have another one for 30. For 30 is just 30 being there, and then in terms of the sides is the same. I hope I got it correctly there. Remember, guys, you must know this by heart. If you don't, you are in trouble, because they say do that without the use of a calculator. So let's see. What is the trig ratio for cosec? Anyone who can tell?
Sine.
Do you guys agree?
Yes, sir.
Yes, sir.
Tabiso, it's not sine, but it's 1 over sine. Nay, it's
Yes,
not
sir.
sine. Sine is a trig ratio on its own. But the inverse or the reciprocal of cosec is 1 over sine. So you write 1 over a sine of 45 degrees divided by, can you see, it's that divided by over there. It's divided by what? Sine of 90. Do we know what is sine of 90? I think it's 1. Is it not 1?
It
It
is
is.
one.
Yes, it's 1. So it's more like we have 1. And then now, what is the trig ratio for tan 60? So you go to
Square
this.
root of 3.
What is it?
Square root of 3.
Do you guys agree with that one?
Yes, sir.
But
Over 1.
wait. I think Shreyas he's cheating, guys. Shreyas, how did you get square root of 3?
So I use the last triangle, sir, that you drew.
Which one? This one?
Yes, sir.
How did you use this one? What did you do?
So since 1 is the opposite of 30, so then I put 60, sir, at the end of the triangle. So I made it as an opposite for the square root of 3.
Oh, okay. No. So on your triangle you have that one. Are you having this one?
Yes, I used an example as the second triangle, sir.
Oh yes. This is the second triangle. So okay. No, you're not cheating, Shreya. So this is the triangle that you use because it has an angle of 60. So you say tan, is opposite over adjacent. Opposite is square root of 3 over 1. When you write it, Shuyas, don't say square root of 3. You'll get it wrong. Because examiner is going to think you punched tan 60 on your calculator because it gives you square root of 3. So don't write it as square root of 3, but as square root of 3 over 1. I hope it makes sense to everyone. So now let's try to continue. We have what is it? 1 over what will sine of 45 be? Let's see. There is 45. What will it be? What is sine of 45? Sine is opposite over hypotenuse. Okay. Do you agree with me on that one?
Yes.
Yes, sir.
Okay. Let's say this is divided by that times that time. This is actually the same as a square root of 3. So let me remove all of this because we've already used those angles. So now let's see. If you multiply that by that, yes, you have to change that to a multiplication. So let's say for now we still have that, and then we say multiply. Obviously there's invisible over 1 there, and then you take that at the top and then this at the bottom. Then you end up having that times that, this times that. So it's more like you have 1 over what is that times that? Is it not square root of 3 over square root of 2? Am I correct in doing that? Yes, because this times that is 1. 1 times that is square root of that over that. Yes. So you have 1 divided by a square root of 3 over square root of that. Then you say 1, you change that to a multiplication. Then you take that to the top, that to the bottom. Then you end up having square root of 2 over square root of 3. Then that times 1 is the same as exactly that. Something that I remember. I think the calculator or the rule doesn't allow you to have a square root of something at the bottom. So the moment you start having a square root at the bottom, I think you must multiply by exactly the same thing as a ratio. If you had square root of million, you're going to multiply by square root of million over square root of million. It doesn't change anything because square root of this over square root of this is the same as 1. It doesn't change anything. So that means this times that is the same as square root of 3 times 2. Square root of the inside times the inside over square root of the inside times the inside, which is 3 times 3. What is 3 times 2, guys? Is it not square root of a... What is it? Is it not square root of 6? What is 3 times 3? 3, 6, 9. Is it not square root of 9? It is. Do we have this thing, square root of that? Square root of 6? No. We cannot simplify square root of 6. It remains a square root of 6. Do we know what is square root of 9?
Yes, it's 3.
Yes, it's 3. So that means the final answer of that is square root of 6 over 3. Yo, I pray that this is correct, guys. How do we prove if this thing is correct? Is there someone who knows? Guys, is there someone who knows how do we prove if this is correct? If it's not correct, then we'll need to redo it. I'm praying that we get it correct. But if we don't, then it means it's going to be a lesson. This is how you prove it. You punch all of that or all of that on a calculator. So you have 1 over sine of 45 multiplied, is divided by 1 into square root of a, what is it? 3 over 1.
1.
It gives square root of 6 over 3. Hey, seems like we've hit a jackpot on this one. Can you guys see?
Yes, sir.
Yes, sir.
Yes, sir.
Are you happy there with that explanation?
Yes, sir.
Yes, I'm happy.
So remember, guys, even if on your calculations you ended there, where you say the answer is square root of 2 over square root of 3, and you don't continue with all of this, you were still going to get your 3 marks. Was it 3 marks or 4 marks? Let me check. I think it deserved to be more than 3. Let me just quickly check. How many marks for this question, guys? Do you guys know? Let's see.
4, sir.
Yes, it's 4 marks. So this is how you score 4 marks on this question. I'm not sure, guys. Did you all understand what I was doing in today's lesson? Did it make sense to everyone? Or were you guys lost? Neo,
But didn't understand.
Neo is gone. Amorelang, Faith, Wise Man.
Yes, sir. I understand.
Amorelang, in which grade are you again?
I'm in grade 12.
Okay, 100%. So, guys, I'm not sure if tomorrow we start something new or do we do some more of trick questions. Are you satisfied with the trick questions, or should we do some more nyana nyana?
Can you please do more?
Who's requesting for more? Who was that?
Lisa?
Okay, so Lisa, let's say for the rest of this week, we'll just be focusing on trigonometry, mainly this type of questions. And then from there, let's say maybe from next week, you can still do questions based on functions. I'm not sure if you guys understand the functions for trigonometry. You guys let me know while we're still on this lesson. Do you guys understand the functions for trigonometry?
So there's function on trig. No,
A bit challenging. Okay, then it's fine. Let's say sometime or before we move to the next chapter, we'll have to do a the trig functions. So guys, thanks very much for joining. You guys have a very good night. My name is Desmond. I hope you enjoyed as much as I did. Good people, I'm out.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Interesting.